My name is Shea. I work at Arizona State University, and I am a GIS analyst and programmer, which GIS is easily described as maps on the computer. So if you want to determine where a flood zone is, you can use GIS. If you want to get onto Yelp to figure out which restaurant you want to go to, you're traveling through Mobile, so you go to yelp.com and you say I'm in Mobile and show me all the restaurants, and then it puts points where the restaurants are, and then when you click on it, it tells you the name of the restaurant and maybe the menu. That's geographic information. So GIS is Geographic Information Systems, and it's a way of getting the things around us onto the computer so that we can analyze them or learn from them or study them in some way. And I work at Arizona State University, and I get to do this all day, every day. So my job as a GIS analyst is to solve problems, a lot of different types of problems. So I have one project where we're studying historical bones and fossils out of Ethiopia. We have a project where we're helping a local utility company to map what they have so that they can do better network. We've had issues where you need to build a new school. Where should you build the school based on where the students are, where the student's going to be, how's the infrastructure to get there. Sometimes you need to close a school. So how do you choose which school to close? If you want to build a Starbucks, where do you build that Starbucks? Where do the young people live? Where the people who like to drink coffee live? How are people going to get there? So one of the reasons I love my job is I deal with a variety of issues, and I just get paid to solve problems for people every day and just think through steps and solve them. So I get a variety, and while I need certain skills, I need to know how to use the mapping software, I need to know how to communicate well with people and talk to them. In general, solving a problem is solving a problem. So I just look at it logically, think of how to solve it, and address it. And I get to deal with a variety of topics, which is nice. So for the Hadar project, which is where we have fossils in the Ethiopia area, what happens is the paleoanthropologists come back from Ethiopia, and they are out there with handheld GPS units. So for instance, your smartphone has a GPS in it, and it can tell you where it is. Well, these are much higher accuracy, and they go out and they find a fossil, or they find a site with many fossils in it. So they get the XY location of that site, and then also known as latitude and longitude. Some of you may have learned that in school. There are different ways to pull your XY location, but they get that information, and for every site, they know where that was located. And they also know every fossil found at the particular site, its kingdom, phylum, class, order, family. I think a lot of us learned this in high school biology. They know who found it, what type of bone it is or fossil, quite a bit of information. So what we do is anything that has a location can be mapped. So we take that XY location and we put it on a map. So this is a typical piece of software that GIS people use. It's called ArcMap, and here's Ethiopia, and when you zoom in, you can see, sorry, imagery makes it a little slow, but we're going to zoom right to anything here. I have photographs of the specimens that are found. So I map them by family, because sometimes perhaps you want to see, here are all the localities. So the important thing about GIS is not only does it know the location, it knows the information behind it. For instance, back to our Yelp example, when I tell it I want to see restaurants in Tempe, it doesn't show me every building in Tempe, it only shows me restaurants. So in this case, I have all of the localities, every single fossil, or actually in this case, the 2,000 locations where they've found those fossils. So I've got all 2,000 locations, and then I can say, just show me the places where you found giraffes, the family that contains giraffes. And these are the locations where they found giraffes. Please remember these are very, very old fossils. So, for instance, the families, a lot of these things no longer exist. Suidae, we're not just talking pigs, we're talking anything in the Suidae family. So we map them, and my job is to map them so that professionals can do the analysis on them. And the professionals have two ways they like to do it. Once I've mapped something here, I think a lot of people have heard of Google Earth. So here's the United States in Google Earth. Well, we wanted people to be able to see their data within Google Earth. It's a nice, easy way for a lot of us to see it. So I've got Google Earth. I've got imagery directly from the project, but I'm going to turn that off so that we're just looking at the imagery from the Google Earth supplies. We're in the middle of Ethiopia at this point, and these are the localities again. So I can hover over a locality and find out at this locality, its number is 477. There's one fossil there, and it comes from one family. If I click here, there were 3 fossils at this site from 2 families. And then if I click on the locality, again, I need to be able to see the information behind it. So it says, at this site, I found a hominid, a bovid, and I have no idea what that family is because I am not a paleoanthropologist. But I can see that I found a horn core, a mandible, part of a jaw, and I don't know what bone that is, so I can't answer that either because the end product, this end product, is not for me. I created it for the final user. Let's go back to the photos. I can also say by total fossils, which sites had a lot of fossils. At these 3 points, over 200 fossils were found at each of these 3 sites. So the researchers can go and look for the different things they need to know. The Google Earth part was also built as a learning tool, both for high school students and college students, maybe undergrads who are studying anthropology and need to learn about this. So if we're looking at different geographies, I can turn on these geographies, and when I click on them, it will tell me, okay, this is the type of geography, and here's a picture of what it looks like. So Google Earth allows them to see the photos so that they can learn about them. If they're studying geology, then perhaps they would want to know, okay, this is a geological trench below this time period, 2.35 million years ago, in a particular basin. So those interested in geology can find out about that. Those interested in locality information, this is what that site looks like where they found this. I'm not going to try and pronounce any of these words because I'll just slaughter them. And then my particular favorite is these are the locations, specimens that they found. So here in AL333 is specimen 105, an Australopithecus, so a cranium. This is the actual one they found, and that is where they found it. And somewhere in here, so I've got the gazelle, horn core, and this is what it looks like. And somewhere in here, let's go back to here in the GIS, and I tell it, please find Lucy. They found Lucy at this particular location. So I open the attribute table, and I'm going to look through the caption until I find Lucy. Let's see where Lucy is. She's right here. And what was her number? I can't remember, so I opened my table. She was found at site 288. So I'll come back to Google Earth. I'll look around for site 288. I click on it, and that is the Lucy skeleton. And if I come back here, I know because I built this, and I say show me the different families and show me the hominids, that is what artistic representation of what Lucy was thought to have looked like. So I have users at the Google Earth level, again, points with information about them. I've got the more traditional GIS users can use ArcMap, a product built for them, And then we also have built websites so that they can do some higher level research. And the websites have the same information on them, but we've built, my job as a programmer, and I didn't program these tools. My job was the client came to me and said, we need a way to map this. So we talked through, how do we map this so that your people can get the answers they want? What types of tools do you need? And then a programmer comes in and builds the tools so that they could say, show me all of the bovids and the suids. So again, I get paid to play with other people's really cool data and help them answer the questions they want to answer. Here's a different type of application we developed. We developed this again for a particular client, which I'm not going to show you right now because of confidentiality issues, but it solved a problem of being able to map data and query it very simply. So we had another issue when people came to ASU, they wanted to be able to find restaurants or parking areas, so we just took the same problem-solving concepts and applied it to our local area. So I'm going to show you how we've solved it locally and explain a little bit about it on the computer, and then the main purpose of this, I've shown you some ArcMap, the GIS software. I've shown you some Google Earth, something we're very familiar with. I've shown you how you can have it on a website, which is something we have now. But actually, if you'll notice, these buttons are fairly huge, and there are fewer buttons on this one. And the reason we've done it this way is we developed this application to run on a tablet. So specifically, I use an iPad, but it'll run on any tablet. So it's got fewer buttons. They're bigger, they're easier to press, and we'll show you how it works on the tablet in just a moment. But in the meantime, I wanted to explain a little bit more about the basics of GIS. So we know GIS, one of the important things is everything in it is geographically located and it's in some way has a spatial relationship with other things in the map. And we deal with those different layers, and we also, I should jump back, remember that there are attributes behind these different points. So if I ask the restaurant about itself, so the picture tells me it's a restaurant, but then the restaurant has a table behind it that can tell me its name and tell me whether or not it accepts ASU's dining plan. And eventually we could add other fields like what ethnicity is your food, or if it's a flash stop, are you going forward or backward? Which bus route are you? All of this information is contained in the table. So when we go to our layer list, GIS works in layers. You group similar layers so that you're drawing it at the same time. So restaurants right here all look like the fork and knife symbol. And I've grouped them all together so that if I see restaurants, I see all of them at once. But if I'm not eating, I'm just parking and trying to get into school, I turn off the restaurants and I turn on the bus stops. These are flash bus stops. Flash bus stops are particular to ASU in that they get you around ASU. Some of them run on the citywide bus routes, but then they turn off and specifically are built to get me from my parking out here into my class. Walkways are also important at ASU. So walkways, I didn't actually draw lines for them, but they are types of lines. For instance, Palm Walk is at, I believe, 100 years old, and a lot of times you'll see an event happening on Palm Walk or on McAllister Mall. So we added these because it's something a student new to ASU would need to get to, and that would help them. There are also performing centers. We outlined those. There are buildings, and if I do an identify on a building, for instance, Coor Hall, this is the building I work in. I click on it, and I see the name of the building and the number of floors. I could also add the classes in it or any other type of information. And then we have parking garages. So GIS works in layers of similar information that you can turn on and off to get the information you need, remembering that there's always tabular data behind it that allows me, it's not just a dumb map. I can ask the map questions. And of course, I've been mapping for about 15 years now. So when I see a map like this, it makes perfect sense to me, and this is how I think. But I'm going to clear that building out right there. I have learned from my experience that most people think more in terms of imagery. Let's see if I can get the imagery to turn on, or if I'm zoomed in too tight. I might be zoomed in too tight. So just like in Hadar, where you could see the background imagery, there it is. Most people are more familiar with seeing what the buildings look like from an aerial image. So you can either view it that one way or another. So let's switch over to we've seen that you can look at the different layers, see the legend. Restaurants look like a fork and knife, parking looks like a P. You can zoom in, zoom out, ask it questions, and then you can, because this was built for a tablet, you can tell it to locate where you are so that you can find the restaurant nearest to you. So let's move over to the tablet and see how it works there. So here it is on my tablet, and I can zoom in either with the zoom in or zoom out button. I can do typical things you do on a tablet, the 2-finger scroll. Right now, all the buildings and words are kind of getting in my way. So I'm going to go to my layers just by tapping it, and I'm starving. And when I'm starving, I don't care about anything else except getting food. So I left my restaurants on, and now I'm going to start my locator. Now this particular iPad does not have a GPS unit in it. My clients can plug GPS units into them, which are about that big, very small, and they can track themselves in the middle of the desert, which is very important to them. But I don't need to do that right now. I'm sitting on a wireless connection, so when I click Start Locator, if there's no GPS unit, then it will use my wireless to locate where I am. And in fact, I am here at Core Hall at ASU. So this is where I'm standing, and I'm starving. So I want to find out what restaurants are around me. So I'm going to identify this restaurant right here. I click my Identify button. I click on the restaurant. It circles it and says, that's Charlie's Cafe. And then I'm a student and I only have my dining card. I've used all of my cash for the week, so it doesn't accept my dining plan. That isn't very helpful to me. So I'm going to click the Query button, which just means query. I need to ask a question. And I want to ask the restaurants, I don't care what their names are, but what I do care about is whether or not it accepts my dining plan. So, do you accept my dining plan? If you do, please show me what you are. And then I hit query, which just means ask the question. It circles everything that accepts my dining plan. It looked to the table and said everything with dining plan equal to yes, circle it. And now I can see I can go to Dave's Doghouse, Einstein's Bagels, Starbucks, Papa John's, Extreme Pita, I think that's supposed to be the Fresh Fix, but I'm not sure. Qdoba, Chick-fil-A, POD Market, Pitchforks, Taco Bell, Burger King, all of these things around me accept my plan. So I can zoom out and I can see where things are circled. That's where I can go. So I'm right here. This is pretty close. I know these accept my dining plan because they're circled, so I'm going to do a quick identify on them. Identify that one. That's Dave's Doghouse. Dave's Doghouse. I love hot dogs, chili cheese dogs to be specific, so I can now walk on over and get my hot dog. So this has been developed. Again, this is something that ASU students would use. We also developed it, a utility company perhaps could use it to find a pole that's gone outside. A roofing company can use it to get to the house that they need to get to. All different sorts of people and businesses still ask the same spatial questions. What's there? How do I get to it? Does it need fixing? How tall is it? How much wire do I need to bring if I'm going to fix it? So this is an example of how on a tablet you can take it with you. You don't have to bring your big computer to the field, and you can still ask the spatial questions and get the answers. To get to GIS, I really lucked out, as it turns out. I majored in geography when I got to ASU. I took a couple of years to decide what I wanted to do, and I majored in geography because I love being outside, and I thought geography would give me a chance to learn more about the outdoors, study something where I could be outside, inside, outside sometimes, inside sometimes. And I thought it opened a lot of, I could do forestry, I could do just a variety of interesting topics for my career path. And I've been a big fan of, my parents taught me, pick something you love, and that's the way to go. So I did that, and as I was finishing my senior year, GIS was really just beginning to bloom. So actually I happened into GIS. I just took a programming class. There were lots of jobs in it when I graduated, and I was able to get a job, so it was fantastic. I love it because the job I have now lets me be outside sometimes in the middle of the desert with a GPS unit, being outside. Unfortunately, clients tend to want a GPS in the middle of summer, but when they want to go out and gather data in fall or winter, it's absolutely perfect. So I get to be outside sometimes, I get to be inside sometimes. And my current job that I've had for 10 years, I love the variety. I deal with different types of clients with different types of specialties. So I get to learn a little bit about each one of their specialties, and they pay me to help them solve their problems. So I get to solve problems, deal with different specialties, deal with a lot of different people who I really like, so it's absolutely perfect. Something I wish I would have known before I went into GIS is I thought everyone can use GIS, so I could get my degree and I could go and be an anthropologist who uses GIS, or I could be someone who worked with animals and used GIS, or I could work for SRP, a utility company, and use GIS. So the great thing about GIS is it can be a career or it can be a tool. And all of the jobs I just mentioned, it would be a tool. If I wanted to be an archaeologist, I should have studied archaeology and learned GIS, like using Excel as a tool or using a GPS unit as a tool. So the GIS allows me to bring in the data, map it, and study it. But I do not have the theory and the background to be an archaeologist. I do not have the theory or the background to work full-time for the Forest Service. If I wanted to study those, I should have studied those and learned GIS as a tool. As it turns out, I am fully qualified in the career path to either be a programmer and help people build programs. Different industries, I can help them build programs, and we have a programmer here. Or I can be a database person, and my job is to help them keep all of this data organized and clean and combine it and look at it in different ways and get it to give the answers that it needs, or tell you what other data will help you get to those answers. So that's another career path that's involved with GIS that luckily I love. I can manage projects and deal with clients and help them solve problems. So there are career paths, but they tend to be more technical. And if you want a career in a different field, then GIS is a tool. And that's just something really helpful to know. When I graduated, my job was to build programs for other people so that computer applications, when they pressed the button, it did what they wanted. It took about 5 to 7 years of doing that before I hit the point where now my expertise is enough that they come to me and ask me to help them on a higher level and write reports or give them answers, which, as it turns out, is what I love. So I'm very happy I happened to fall into this career 15 years ago.